0. Okay. 0 minus 1 minus 1 minus 2 to 1. Okay. And it follows the order of the y elements in the original array.
Yes, stability with y.
What did you say?
The order should be same as the array element, right?
Yeah, the y element, right? In
Yes.
the original array. Yeah, so yeah, let
Y,
me.
y should be stable.
Oh, okay, yeah, y is stable. Okay,
Yes.
okay. So 0 minus 1 minus 2, 1. Yeah, I think, okay, yeah, this example makes sense to me. And for the second example, there's no possible pairs. I see. Okay, so maybe, yeah, let me see if there's something unclear I need to ask. Yeah, let me try to check. Okay. Oh, k is greater or equal to 0. Yeah, let me take a note. Oh, so, but the elements in the array are distinct, right?
Yes, yes.
Okay, yeah, so I guess I don't need to worry about the situation where a k equal to 0 because every element are distinct. Okay, yeah, okay, and the order. Yeah, I guess there's no remaining ambiguity to me. Yeah, I think I can start think about the ideas, or maybe just some edge cases. If input array is just one element, should I return or and k equal to 2 or something? Uh,
Mm,
okay.
so one element I think empty arrays should be written, right?
Yeah, so this case I should return empty array, right?
Yes, yes. Because equation not satisfy x minus y equal to k.
Okay. And maybe my another question is it a guarantee is it allow that x equal to y if when k is 0?
Yes.
Oh, is it is it is possible?
Yeah, yeah. Because it is input k equal to 0 is given.
Okay, so yeah, let me just double check with you. So array, there's only one element here, and k is 0 here. I should return actually one a pair of 1 and 1. Is that is does this is it fits your expectation?
I don't think because array element is distinct, so necessarily another element is required. So duplicate is not allowed, right? So x equal to not y. Understand?
Oh, so s could not be y, right? Is
Yeah, because all are distinct.
okay, and can I use the same element for x and for y? I know all
If
elements are distinct.
k equal to 0, we don't use same element two time, right?
Oh, so we cannot use same element two times.
Yes, yes, yes.
I see. I see. Yeah. So s equal to y. Okay. Yeah. Let me just type saying not x y should not be same element. Yeah. And in that case, in this case I should still return empty array. Yeah. Is this fits your expectation?
Yes, this is right.
Okay. Yeah. So yeah, I think yeah, I currently have no other questions, and I can think about the how to approach this. Um, Yeah, so let me think. I want to find pairs and follow the order of y is the smaller element in the pair. I see. So I think my idea is like this. Like for each y, I go from left to right to check all possible y, and for each y, I want to find an x for it. So something like this. For y from left to right. Yeah, this is basically my plan. And I think to achieve that, I can um, I think I can just throw every element into a set, so I can quickly know my whether a value is in the set, so that I can quickly find an x with the
Yes.
y. Yeah. Okay. Yeah. So yeah, this is my plan. Let me type it down. Use a value set to find x. Yeah. And I also need to be aware of the case we just discussed. I think when k equals to 0, I always sorry, return, I always return
Okay.
empty array. Yeah, because I cannot use the same element twice. Yeah. Okay. Yeah, I think that would be my plan. So if everything sounds reasonable so far, I can try to estimate the complexity. Okay. Uh, so the complexity to throw every element into a set is linear time, and
Okay.
find an element in a set. If we doesn't count the hash collision, it will be a constant time. Yeah, if we ignore the hash collision, and yeah, and try every possible y, also linear time. So I think overall, uh, it is linear time. Big O of n is the size of the array,
Okay.
and space big O of I have a set to keep, so that would be yeah also big O of n.
Okay.
Yeah, yeah. I think that is current best approach I have. I was also thinking about maybe I can sort the the array, and maybe with the sorting I can also efficiently find the x I want. But since I also need to I need to be aware of the original order of y, right? Because I need to keep the order of y in the output. So I guess sorting uh, is not very ideal. I still need to have some space to keep the information of original order. So yeah, I guess this approach, the current approach I have here is
So
the
you are
best.
sort
Yeah.
the input array, right?
In this, the current approach, I don't sort.
Okay. Okay.
Yeah.
You take sorted.
You say you are you saying I can sort it?
You are traversing from left to right in the array, right?
Yes.
Then how you find the x?
Okay. Yeah. So use this value set. So
Okay.
yeah, yeah. So what I want to do is this value set I want to put every element in the array into a
Okay.
set. Yeah, so try to find the x from the set. Yeah, this is what I want.
Okay. Okay. And set is unordered, right?
Set is on order, right? But y is in the original order. Yeah, this
Yes.
is what I want.
Okay. Okay.
Yeah, yeah. So, does everything sounds reasonable so far? Could I start implement it?
So how you get X?
Oh, okay, yeah, I can. Yes, let me do that. I can try to find the x if uh, I want to. The difference is k, right? So k plus y. This is the target x, and I check if it is in the set. I find it. After I find it, I push it into the result. Uh, yeah. Oh, x comes first and y comes next. So maybe yeah. Let me have a variable x.
Okay. Okay.
Yeah. So sounds reasonable to you.
Yes. 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 I
Yeah.
think it's the correct solution.
Yeah. So could I try to write the code? And
Yeah. Sure. Sure.
yeah, yeah, yeah. So let me paste my current pseudocode below and make it a Python code, valid Python code. Let me do that. So first check is k is 0. If k is 0, I return empty array and then set loop for y in array, try to find x. If x is in a set, return the result. So I need to have the result. Yeah, finally return it. Yeah, let me do a check. Um, k k plus y. So x minus y equal to k. This is what I want. And
Okay.
x in value set result. Append it. Yeah. So yeah, I just check my code and I am quite confident with that. So do you want me to do the dry run, or if I am confident, I can directly run the code, or do you want to ask questions?
So run code.
Okay, yeah, let me run the code. Okay, no syntax error, so let me run the test. Yeah, it's passed the test. And for complexity, I will stay with my original plan. So big O of n for time, big O of
Okay.
n for space. So yeah, so far looks good. Do you have a or you have other questions?
Is there any solution for this question? Any other solution apart from
Oh,
this?
other solution. I see. Other solution. Yeah, I was thinking about sorting. So sorting. Um, if I sort the array,
Okay.
uh, I can maybe I am thinking about maybe I can use two pointers to find the the pairs. Yeah, so yeah, maybe I should take some examples. Let me have an example. Yeah, maybe this example. And I can make it maybe a little shorter. Yeah,
If
maybe
you
just a
do
certain.
sort, then order is disordered. Then how you stable with y?
Yes, yes, you are right. So I need to keep original order of y, right? So I need to maybe have a something. I need to keep the original order. So I don't directly sort the array. Maybe I can have a copy of it.
Okay.
eh, Uh, something like this. So the original array does not change, but I have a
Okay.
copied sorted version. Yeah, so let me do that. And if I do that, I can have a this. Okay, it is already in the order, but
Okay.
yeah, this is what I want. And maybe and for this, um, I can start maybe do run my two pointers. One pointer for uh, x and
Okay.
one pointer for y. X is the bigger one, y is the smaller one, and yeah. So what I will do maybe is something like this. Initially, x is here, y is here, and
Okay.
I do found a pair here. So it's oh oh I said I should keep it sorted. Um, I want to it I want it to be sorted ascending in ascending order. Yeah, so this is what I want. And again, I have a x, I have a y, and check if I have a pair. So no, then there's oh yes, I do have a pair here. So it is -1, -2. Yeah, and then I move my x, my y is still here. And
So what is the benefit of sorting here if your second pointer is move uh, in linear fashion?
I see. So, you are, yeah. Let me make sure you are asking what is the point of sorting if to help my two pointers. The are you asking this question?
My question is you use two pointer, right?
Yes.
And two pointer are pointing zeroth and next element ith and I plus 1, right?
The 2 point. Sorry. Could you say again? The two pointers are.
Where the pointer pointing first pointer I and next pointer I plus 1 or same at I or at the end where it is?
I see. So, initially, x is pointing to the second element. Y is pointing to the first element.
Okay, means
And
I and I plus 1, right?
I and I plus one, right? And I initially to be zero, but
Okay.
it is possible for x to be not neighboring to y. We want x. This is the property I want. Y is smaller than x. This is what I want, and it is
Y
not
is smaller
necessarily.
than x, okay, but in the question you written in answer y is smaller than x, right?
Um. Oh, y is smaller than x. Why is it? It must be y must be smaller than x, right? Do you agree with that? Because x minus y equals k greater equal to 0 and k equal to 0, there's
Mm,
no answer.
y is x minus k and x is k plus y. Yeah, yeah, I agree this.
Yeah, yeah. So y must be smaller than x.
Yes,
So
yes.
yeah. So for the two pointers, x must be right to the y, right? If I sort the array.
So you are going linear way or binary search?
Linear, it's more like a linear, not a binary
So
search.
means I at the point of 0, and let's assume you pointed x in somewhere, right, in the array.
Yes, yes.
Okay, means current position is y position, right? I
It's
position
me.
is y position, because at the I y is there, then I plus 1 is sorted, so next is greater, right?
Oh, so you are talking about the y is at I,
And x should
uh,
be on the right side.
x, x is could be I plus one. It could be I plus two. It could be I plus three.
So
It
here
depends
how
on.
you find x in I plus 1, I plus 2 or something, what you do? I am asking this.
Yes, yes. So actually, so I am not focusing on y. I am focusing on x. So could I say x is at I? Could I say
Okay.
this? Yeah. Let's focus on x. Yeah. And y is just as I just say it is initially 0.
Okay.
And so I want to look through every possible I, right? Every possible x. Yeah. And so this is the example where now I have the second iteration here where I equal to 2. In the beginning, I equal to 1. And then now I equal to 2, right?
Yes.
And then I found y is too small because x minus y is greater than k. So this is what I want to do. Move y if x minus y is greater than k. It means y is too small. So I move y. I move y to here. I move y
Okay.
until uh, x minus y is equal to k, or I can say greater or equal to k. It depends on whether I found the answer or not. I found a possible pair or not.
What is the expected time complexity for this solution?
I think it would be still big O of n time for time complexity. For space,
No,
it is
time.
sorry. What's your question?
Time complexity.
Oh, so are you asking why the time complexity is n or big of n?
No,
Are you
sorting
asking?
required and log n, right?
Right, you're right. I missed that. Yes, you're right. Thank you for reminding me. So I think it would be n log n instead because it's have a sorting. Yeah, yeah. Thank you. Yeah, because for sort plus two pointers, it's overall n log n. You're right.
Okay. So okay, let's swap the role.
Okay. Yeah. So we can swap the rows.
Pancake sort. Given an array of individual write a function. My language is C++. Given
Okay.
an array of individual write a function. Flip air and k that reverse the k, order of the first k element in the array. Okay, write a function that sort the return and the input array. You are allowed to use only the function flip. You can note the first. First. in this question we need to sort the array, and we
Yes.
are allowed to write a function flip that reverts the order of first k element in the array here. Okay,
Yes.
we just use this flip function and sort this array here, right?
Yes. We can only use the flip to sort the array.
So we need to write a flip by myself, right? It's
Yes. You need
uh,
to implement the flip function yourself.
another time and space complexity. Pancake sort because it resembles sorting pancake only plate with and k should be greater than equal to 0 area. Okay. We are given the input array. Okay. And we assume k would be 0, 1, 2, anything, right?
Yeah, it could be anything greater or equal to 0, any integer.
Up to the length of the array, right? Maximum k.
All right. You're right.
K, k, k greater than equal to 0 and k less than size of array. And we just sort by the reverse. Let's take this input here and compare this, it is greater. Okay, here in this example this input array, right? So first it is 1 greater than 1 is less than 5, right?
Yes.
This is a correct position, and 5 is greater than 4, so it is not satisfying because we need
Yes.
to sort it in ascending order. Okay, so
Yes. Ascending order.
at this position 0 1th index. Okay, so we flip we we flip we reverse this function 5 and 4. Okay, we pass this and value pass k equal to 2 from this. So after passing the flip the array like that, 5 here and 4 here, right?
I have a question. So K is 2. It means flip the first two elements of the array, right?
mm, uh,
So yeah, if K is 2, it should flip the first two elements of the array.
but if, so it is necessary to start from the starting, right?
Yeah, we must start from the starting when we
We
flip.
not start from here, 1th index.
I think we cannot start from one index.
Okay, let's. Okay, so initial the step one is like that. We traverse from this 0th index. Okay, and
Okay.
up to going to the end index, right? and
Okay.
find the minimum minimum array index. Okay, so
Minimum value,
minimum
right?
value index.
I see. I see.
So minimum
Okay.
value index is at 0, right?
Yes.
So reverse from this and okay, okay. In my mind, one case is coming. Firstly,
Okay.
we need to find the maximum element index. Okay,
Oh, maximum. Okay.
maximum is present at the index 1, right?
Right.
So now we need to pass a flip with value k equal to where the maximum present. Okay, so
Uh, yeah. Could you?
it look
Yeah.
like 5 and reverse 1, then 4 comma
I see.
3 comma 2, right?
I see. Okay.
Then now pass flip to entire size. Then after this it look like mm, 2 2 3 2 3 4 1 5. Okay,
Okay.
now the last element in sorted order. Okay,
Yes.
now in the uh, before skip the last element, forgot the last, now working on uh, initial 4. Okay, we
Okay.
we find the 4 in 4 at the index 2. Okay,
Yes.
now reverse the first 3 element where the it is present, it reverse, so it look like 4 3 4 3 2 4 4 3 2 4 3 4 3 2 4 3 2 1 and 5, right?
Yes.
Now pass flip the last 4 initial 4. Okay,
Okay.
now 1 2 3 and 4 and 5. Okay, last 2 is correct
Yes.
position.
Yes.
Now initial 3 is only it is correct position, but it may not be. Okay, but it necessarily last 2 is correct position.
Yes. That's two must be correct.
We do the
I
same thing.
agree.
We do the same thing in entire array. After the this then the entire array is sorted. You got my point?
Yes, I agree. I think this is a good approach. Yeah. So, what would be the capacity for this approach?
Mm, firstly, we are finding the maximum element in. Okay, so it
Yeah.
took order of n, and then we are flipping function. Flipping function is k. Okay, so n into k, right? And k k k maximum less than equal to max of len of array, right? So in worst
Mm,
case, if assume k equal to s, that's order of n square. Worst case.
so angles. I see. Hmm. Okay. Yeah.
And
Uh,
space is order of 1 because we don't use any extra space.
hmm. I see. Yeah, I agree. Yeah, it looks good. Yeah, looks good to me.
Okay, we need to code this.
Yes, I think you can call
Okay.
this.
Let me first write a flip function. Okay.
Okay.
Right.
Okay.
This is a flip function. We reverse the first k element. Okay. Now we are going to do the here. Now max index is I. J less than I. If array of I means current element is greater than array of max index, okay,
Okay.
then max index is j, right?
Okay.
Now we just flip the array and the max underscore idx plus 1 flip array comma dot size minus I. So initially I think it should be work. Can I dry run or run the code?
Uh, I have a question.
Okay.
So, what does it mean for I equal to 0? Oh, do you want to dry run? Are you asking you want to dry run? Maybe I should let you dry run first.
I equal to 0 starting point.
Starting point of what?
Starting point of the index I0 up to the n element iterating,
Okay.
and after that we are going to finding which is the max element in the array, and assuming the assuming the only working on the skip the last I element, because we know only the remaining part except the line in first iteration we first iteration the one element is sorted, in second iteration the one element is correct position in last, so only n minus one element, so we only iterate j in error dot size minus I, right?
I agree.
In this is the condition finding the max, and after this this should be after the loop, and now this is after this we have the max index. Now the max reverse the max index, the max index in the starting position, and after that max element in the last position, last unsorted position,
Yeah, I agree. I agree with this logic.
right?
So Yeah, but I still have a one question. But maybe I should let you do the dry run first, if you
Okay,
want.
let me dry run this again. Okay.
Okay.
Mm, Here in the line number 25, we put the array. Okay.
Okay.
So first line I equal to 0. Okay. 0
Okay.
less than array dot size equal to 5,
Okay.
right?
Okay.
0 is less than 5, it is right. Okay. So we
Okay.
assume max index equal to equal to 0, then max index equal to 0, right?
Right.
We come to the second loop, j I plus 1. So I plus 1, and we go j less than array dot size. Array dot size means 5 minus I 0. So 5 1 less than 5, it is correct, satisfying. So it goes inside, and 1 5 is in a for loop, if loop, array of j means array of j means 1th index, which is 5. 5 is greater than array of max index. Max index is 0, it is correct. So max index is 1, right?
Right.
After the execution of this loop in max index, it is 1. You agree with this? Because 5 at the 1.
Um. Okay. Yeah. Yeah. You are right. You are right.
Now flip array max index plus 1. Max index is mm, flip the array with max index plus 1 means 2. Okay, so reverse the 2 element. So after reversing
Yes.
the 2 element, it is like 5 1 4 3 2, right?
Right.
Then flip the array dot size minus I. Initially I is 0, so flip the entire. Okay.
Okay.
So it look like 2 3 4 1 and 5, right? Now the 5
Right.
is in correct position. Okay.
Yes.
Now we came again. Now I increment I 0 to 1. Okay. So
Yes.
1 is less than 5, it is correct. So max index is 1. 1. Okay. So max index is at 1. Okay. It is goes to correct here. Again it is right.
Yeah. This is what I want to ask.
Yes, yes. Again we have to starting from the 0.
Yes. The max index should be starting from 0.
Yeah, yeah. Oh, yes, yes. This is something we assuming that again for max index always start from 0,
Yes.
and it is always start from max idx plus 1. Okay.
Yes, I agree. Yeah. So
Now this
yeah.
is correct.
Yes, I think then I don't have other questions. I think your logic is correct to me. Yeah, you
Yeah,
can.
yeah.
Yeah, if you are confident, you can run the code, run the test.
Now I can run this, right?
Yes. No matching function. Not sure. Why? Maybe I'm not sure about C++, but
Wait, I will correct this.
okay.
This constant.
Okay, yeah. So no syntax error. Yeah, it says finish the executing the code. I think it means it's has no compiler error.
Yes. What? It is finish exiting code.
Because it doesn't have any example inputs, so it's just a finished. So if you want to have a test input, you can run the test, either run the tests or you can call this
Yes,
function
yes.
in your main function. Pancake sort. Uh, oh, so yeah, it's still requires a const.
Okay.
Yeah, but it is also weird to me that
Let
how
do
do
the
we
code.
flip it with a const? Uh, oh, it's a copy. Okay.
Yeah.
Yeah. Yes, it's pass all the tests. I think the const part is weird, right? Why we have a const? I mean,
They don't
I
want
mean,
to change their array.
yeah. Although they don't want to change the array, it's asking you to do the flip. So it sounds weird.
Yes,
Uh,
yes.
the question description, yeah, the question code is weird, not your code. The question code is weird. I'm looking at the solution for C++. So there is no const for the pancake sort. So I guess maybe that this is some mistake for the question code. But your code, your implementation is good.
So, any suggestion, feedback from your side?
I guess my suggestion, yeah, would be first clarify the definition of a flip, right?
Okay.
Because we we later know that the flip should always reverse the first k element, not arbitrarily k element. So you cannot start
Okay.
from I equal to 1. You can only start from I equal to 0.
Okay. Okay.
Yeah. Yeah. So yeah, this is the thing. Maybe better to be clarified in the beginning of the question. And yeah, and yeah, mm, I think you give a very a detailed explanation for your idea, and your idea is very good. I think I can feel that. So it is very clever to come up with a
Okay.
correct idea within 7 minutes. I think you you spend 7 minutes to come up with the idea, and I think you are the first one to come up with correct idea that quickly. yeah, I have a get this question as an interviewer for maybe 3 times. Yeah, I think you are the most fast. You are the one to come up with the correct approach. The most quickly one. Yeah, so that is good. Yeah, and maybe another suggestion,
Okay,
just
okay.
some detail about the index. Yeah. So you illustrate your idea. You didn't talk about the index very much. But yeah, I guess yeah, maybe just be careful about your index and the max index thing.
Yes, yes,
Yeah,
yes.
so yeah, so maybe you can also add your illustration when you talk about your idea. So illustration about how you find the max index. Yeah, maybe that would help.
Okay,
Yeah.
okay.
So yeah. So I guess yeah. I guess you overall did is very good. It is very good that you just spend maybe less than 20 minutes to get the correct
Yes,
finish the
yes.
correct answer. Yeah. Yeah. So that is good. Yeah. That's all from my side.
Okay, okay. Which country you are from?
Oh, I'm from Taiwan.
Taiwan.
Taiwan. Yes, Taiwan.
Okay,
Uh,
okay.
I can type it if you Taiwan. Yeah, it's in the line five. Where are you from?
I am from India.
I see. Yeah,
Okay,
yeah.
let's connect on LinkedIn. LinkedIn. You have LinkedIn?
Yes. Yeah, I can send you. I can pass my profile.
Okay.
Yeah, but yeah. Let me pass it. And I haven't asked for your feedback already. Maybe you can do it later. Yeah, let me pass the LinkedIn first. Yeah, maybe it takes some seconds for me to find my profile. It's here. Let me pass it.
Are you a student or professional?
What's your question?
Are you a student or a professional?
Oh, I have a working experience. Yeah. Although
Okay.
I am currently unemployed. Yeah, but I have a 2 years working experience before.
Machine learning, right?
Uh, Software. I was backend engineer and sometimes touch some machine learning. Yeah.
Okay, okay.
Yeah.
So
What
thank
about you?
what?
What about you?
I have 1 year of experience in IBM as a Java developer.
Oh, so you're a Java developer. You were Java.
Yes,
I
Java
see.
developer in IBM.
I see. And I think you also write good C++ code. Yeah, it's good.
Yes, yes.
Yeah. So, do you have any feedback as an interviewer for our practice?
Mm, One feedback is there. The your second approach is little bit not up to the mark. And the first approach is very fine, but second is little confusing.
Second one, little confusing.
Yes, yes.
I
I
see.
think in second approach, I was expecting a brute force solution,
Oh,
which
brute force.
yeah, yeah.
Okay.
In sorting, we need to if you dry run after the sorting, we need to iterate this again. You know,
Uh, you mean after the sorting, what I need to do?
Uh, when you sort the array, then the y is jumbled, right?
All right. Yes. Yeah, that would be an issue. Yes.
So after
I need.
jumbled y, so again you need to traverse unsorted for the stabling, stable, stable the y, right?
Yeah. Right. So I guess yeah, that would cost a linear time to restore the original order, right? Is that what you are concerning about?
So I think for two for loop is right one.
Two
Two
for loop.
nested. First taking the y and finding the entire the x in entire. So it required order of
I
n
see.
square.
I see. Brute force approach. I
Yes,
see. I understand. Yeah.
and the space is
Uh,
constant.
all right. So more a bigger time complexity, but a smaller space complexity. Yeah,
Yes,
that's why brute force is also feasible.
yeah, yeah.
I see. I want to maybe have another thought. I'm not sure whether this is correct. So maybe yeah, I have a list array a value to original order. If I keep this uh, original order map, it is a map.
Okay.
It's maps. It is a map from value to its original order. Uh, yeah. So if I do a map, I don't need to do have an additional loop, right? Original index. Original index. Yeah, it's like something I have a set in my first approach. Yeah, if I can just map the value to its original order for y, I think it could be more efficient, right?
Value with original index, right?
Yes,
Now after that you sort.
yes,
After the sorting, then okay, then according to the original index you maintain the order, right?
yes. I can use this map to
Yeah,
maintain the.
this is fine. This is fine.
I see. Yeah, I just want to know whether this works.
Yeah,
Oh,
this one is correct.
I see. So this would be time complexity and log n space complexity n. Yeah,
Yeah, yeah,
but so I understand that brute force has its advantage because it has space complexity just of one.
yes,
I
yes.
see.
Because in order of n we achieve order of n time.
Right,
Because
right.
order of n time we achieve order of n space in order of n space we achieve order of n time, right?
What did you say?
I am saying that in the order of n solution, order of n space solution, we can achieve order of n time complexity.
Right. So this is not a better solution.
Yes,
This
yes, yes.
sorting solution. I see. Yeah. So yes. So I should not consider this solution. I should consider brute force solution instead.
Yeah,
I
brute
see.
force solution is better than this.
I see. Yeah, I can see that. I
You
can see
agree
that.
this?
I see.
Okay,
Yeah.
okay.
Thanks. Yeah. Thanks for sharing the brute force idea. Yeah. Thank you for
Yeah,
that. I haven't think about it. Yeah. Thank you. Yeah,
thank you,
and thank
thank
you
you.
for practicing with me. Yeah.
Yes,
Yeah. Have a good day.
good. Thank you for your time. Bye.
Yeah. Thank you for your time. Bye bye.